So it is good to know how to deal with more complicated rational expressions. So like when we have fractions embedded in fractions. So we have some easy simplifications we can use if we understand how they work. So for example, if I have 3c divided by 2b, all divided by 3d divided by 2b, this simplifies to just 3c over 5d. The 2b's actually cancel out. So how can we justify this? Well, there's a couple ways we can do this. One is the simplest way is just to show this as, well, if I divide, I'm going to take my 3c over 2b in the numerator. And instead of divide, I'm going to change it to times. Okay, so instead of dividing, using that divide, I'm going to multiply by the reciprocal. So my reciprocal ends up being 2b all over 5d. Okay, and we can see that 2b's cancel out, and we end up with 3c over 5d. So we can just show that simply by multiplying by a reciprocal and show that those cancel out. The other way to do it is a little bit, I think it's a bit simpler. If we understand fractions as top is times, so times on top, and divide on bottom. And really, in a fraction, it's either times or divide. There's not anything in between. We actually have a divide by 2b here, and we have a divide by 2b, which is really a multiply by 2b. Well, essentially, those cancel each other out. 3c's in the numerator, we're dividing by 5d, so 5d ends up in the denominator, 3c ends up in the numerator. So we can keep track of this by just determining the times and divide. So we can cancel the 2b factors since one is times, the other is divide. Okay, so these can be canceled out because of that fact. And we can actually see that when we rewrite it like this, when we multiply by the reciprocal as well, that it does show the same thing. So either strategy is perfectly fine, but again, if we can simplify the way we look at rational expressions as there's just a times or a divide, it's either in the numerator or the denominator, we can simplify our thinking. So if we take a look at a ratio 9 to 8, 18 to 16, these are equivalent ratios. And balancing this ratio, we just use a multiplying factor of, in this case, times 2 and times 2. Okay, so when we talk about ratios and rationals and rates, we're talking about times and divide relationships, and we're talking about multipliers and divisors. So is this the same as balancing a fraction 9 to 8 or 8 to 16? The answer is going to be yes. Okay, because really, again, we're just finding a multiplier of times 2 between the two equivalent fractions. So a strategy for dealing with complex rational expressions is when we have fractions embedded inside fractions. One way to think of this is, well, we don't want to deal with these fractions. Okay, I don't actually like this divide by 2 and this divide by 3. Well, how could I get rid of a divide by 2 and a divide by 3? Well, I can multiply the top and bottom by the lowest common denominator. Okay, and this is actually not GCD, but it should be LCD. I'll change that on your notes. But we're going to multiply by the lowest common denominator, and that allows us to get rid of the extra divides that we don't want. And as long as I do the same to the top and bottom, I keep the ratio balanced. Okay, and that's the same as, balancing a fraction. We're just keeping that ratio balanced. We have a times and divide on top. Okay, so in this case here, if you want to see how it looks in this form, it would be, we can just show that our times 2 times 2, and that would be the same as what we're doing here. We're just going to times the top by 6, the bottom by 6. And what ends up happening then is, It allows us to get rid of these extra divides that are embedded in the fraction, especially with these binomial pieces, because we can just distribute that multiplication. So 6 times 1, 6 times 3 over 2 gives us 9, and it allows us to clear out these fractions. So 6 times 4 is 24, 6 times 5 over 3 works out to be negative 10. And then we can just combine these terms. Now hold the numerator just as in whole terms now. There's no fractions involved in the numerator. The denominator is in whole terms. Okay, so there's no fractions in the denominator. So now we just have everything as times and divide. Okay, so this is a very useful strategy, especially when you have these binomial pieces or extra denominator or extra fractions embedded inside the fractions.